Morning, Year 9. Right, I apologise that the PowerPoint is a little bit wonky, but I'm having a couple of camera issues this morning. Right, so we're going to talk about power. It's more calculations, but because you've done lots of formula triangles recently, it shouldn't be too difficult. Okay, so first of all, you're going to pause the video and then you are going to have a go at these true or false questions, and then I will give you the answers when you press play again. Okay, so number one, the earth wire in a 3-core cable is usually brown. That's false. The earth wire is the yellow and green one. Okay. Number two, appliances with metal casings are supplied with 3-core cables. That's true, because the earth wire acts as a safety feature. Fuses stop current flowing through a circuit by melting when the current flowing through them is above a certain value. That's true. Fuses are a safety feature, and we'll work out how to decide which fuse to use at the end. A circuit breaker works by monitoring the difference in current between the live and the earth wire. That's false. It monitors the current between the live and the neutral wire. And the last one, mains electricity uses direct current at 100 hertz. So that's wrong on 2 counts, because first of all, mains electricity is an alternating current, and secondly, the frequency of it is 230, 240 hertz. Okay, so correct those for me. Right, so you've looked at power before in the energy unit in terms of it being the speed at which something transfers energy. So it's the energy transferred divided by the time it takes. So for example, a 2000 watt hairdryer will transfer more energy per second than a lamp, for example, which is at 500 watts. Okay, so the bigger the wattage, then the more energy it's going to be transferring, and that tends to be things that get particularly hot, so things like hair dryers, etc. They're going to transfer more energy per second. Now we're going to look at it in a slightly different way in a second. So for example, you've got a fan that transfers 1800 joules of energy in 60 seconds. Its power rating, we're going to do our energy divided by the time, which is 1800 divided by 60, which gives me a power rating of 30 watts. Okay, and then you can pause the video again and have a little go at this one. So you've got a hairdryer that's rated at 500 watts. How much energy will it transfer in 1 minute? Now don't forget to transfer the 1 minute into seconds. Okay, and how you would do that is you would take your power rating, so it will be this time the power rating multiplied by the time, which would give me 30,000 joules. Okay, so like I said before, things that get hot tend to transfer more energy. So for example, a hairdryer will turn electricity into heat and movement. That will use more power than, for example, a lamp. Okay, so even though the lamp does get a little bit warm, it will still transfer less energy per second. The toaster again gets hot, so that's going to be heating up to make your toast, and that will transfer a lot of power, a lot of energy too, so it will have a high power rating. Okay, now for part of the electricity unit, what we need to do is look at power in a slightly different way, and that's thinking about power and current and voltage. So in this case, the formula for power would be power is the current, so remember that's I, multiply the voltage, which is V. Okay, power is still measured in watts, and 1 watt is still a transfer of energy, so 1 watt is still the equivalent of 1 joule per second. This is the energy part, but we can actually work out the power using the current and the voltage. Okay, so in this case we've got a changing of the units exercise. So first of all, you've got the K idea here, which is for kilo, and that is always 1,000. So you've got 1 kilovolt is 1,000 volts, 1 kilojoule is 1,000 joules, 1 kilowatt is 1,000 watts. So you've got 3 questions that you can transfer these values into the correct unit, okay, by thinking about this kilo. So stop the video and have a little go at those questions. Right, so for the first one, you've got 6 kilovolts. If you've got 6 kilovolts, each kilovolt equals 1,000, so you would have 6,000 volts. In joules, you've got 12.3 kilojoules. Each kilojoule is 1,000, so that would be 12,300 joules. And then the last one, you multiply that again by 1,000, which would give you 600 watts. Okay, so I've got less than 1, so I know it's going to be less than 1,000. Okay, So now you're going to transfer them the other way around from volts and joules and watts into kilojoules and kilowatts and kilovolts. Okay, this time you're going to divide by 1,000. So pause the video, do the questions. Right, so 9,000 volts will be divided by 1,000, so it's 9 kilovolts. Remember, if you're dividing by 1,000, you move your decimal point 3 places, okay? So if its decimal point is here, I'm going to go 1, 2, 3, which is where I get my 9. In this case, I'm going to move it 1, 2, 3, so that's going to give me an answer of 23.5. And this one, I'm going to go decimal point here, 1, 2, 3, which will give me 0.325 kilowatts. Okay, so that's just transferring between units. Right, okay, so like we said, power is the rate of energy transfer, and it's 1 joule per second, because a joule is a measure of energy. Now we're going to think about it in terms of current and voltage. Okay, so this is the formula triangle. They work in exactly the same way as you've done before. You cover with your finger the thing that you are trying to find. So if I wanted to find power, then it would be, current multiplied by voltage. If I wanted to find out the current, then it would be the power divided by the voltage. And if I want to find voltage, just move my hand around. I'm going to cover the voltage, and it would be power divided by current. Okay, so this works through an example for you. So like I said, if you're trying to find the current, you would cover it up, and that would give you power divided by voltage. Okay, so just as an example, you've got a filament bulb that has a potential difference of 200 volts, and you've got a current of 0.2 running through it. So you should underline the values that you know. We want to know the power. So power is going to be current multiplied by voltage. I'm going to do 0.2 amps multiplied by 200 volts, and that's going to give me 40 watts. Okay, now then, in this case, you can use that idea, okay, to figure out which fuse to use in your appliances. Now, fuses come in 3 different types. You've got 3 amps, 5 amps, and 13 amps. Now, remember that a fuse is designed to melt if too much current flows through it. Okay, now I've got a voltage here of our mains electricity of about 230 or 240 volts. Now, if I do 12 divided by 230, that gives me a current of 0.052. So I would need the smallest fuse for this case, which is why it's been given as the 3 amp fuse. Okay, for the toaster, if I do 750 divided by 230, that gives me a current of 3.26. So the toaster needs a current of 3.26 amps in order to be able to work. Now, if I put a 3 amp fuse in, every time I switch my toaster on, the fuse would melt because it needs more current than the fuse will allow through it. Now, I don't want to have too much, so I would use the middle size fuse in that case. Okay, I would use the 5 amp fuse for my toaster. If it's something like the kettle, so if I do 2,200 divided by 230, then I'm going to end up with a current of 9.56. So again, this time I can't use a 3 amp fuse because it would melt as soon as I turn the kettle on. If I used a 5 amp fuse, that would also melt as soon as I put the kettle on. And for my current of 9.5, I can use a 13 amp fuse. So that provides enough current to go through the kettle to allow it to work. But if too much goes through, then it will still melt and actually save me from getting an electric shock. Now, you'll need all of these ideas for the sheet that is on Class Charts, okay? And I will put the answers on tomorrow. Okay, bye.